Hello everyone. So today is our second lecture of the semester, and just letting you know that those of you who need closed captioning, that is available. I had already talked to a few of you about this, and so this is how you get to it. All right, just follow these instructions here. You have to click on to open the caption window. All right, so that's what you see there. And if you're wanting to save the chat, whatever students are talking about, or the whiteboard screens, you can do that as well. So there's an option at the top that says File. You save it, and then you could save the chat. You could save the whiteboard. That's probably what you would want to be saving. If anything, save it as a PDF. And that way you don't have to write down everything I write down. You can just have an electronic copy of it. Or if you like to write it down, then that's fine too. It just gives you some options. And we don't have a webcam. With this many students, it's not, I don't use it, so. Okay, and I may use it later in the semester, but for right now, I'm not going to use that. Okay, so we finished chapter 1 last lecture. And you have homework that's associated to our chapter 1. And so you want to make sure that you are looking at the due dates to make sure that you get that done on time. All right? So today we are covering chapter 2. So after this lecture, after the chapter 2 lecture, I want you to go to my stat lab, and I'm going to share the desktop with you so you see what I'm talking about. So when you go to my stat lab, you're going to go to homework, and then under homework for lecture 2, you have a lecture 2 assignment. Remember, that's how I keep track of whether or not you have viewed whether or not you have viewed the lecture. Okay, so someone just signed up with my name, which I'm going to drop. You have to use your first name and your last name. All right, so make sure you log in with your first name and your last name. All right, don't log in with my first name and my last name. So yeah, someone just logged in with my first name and my last name. So make sure it's your first name, your last name. Okay. All right, so when I'm done with lecture 2, then you're going to click on lecture 2, that's under the homework, and then you're going to answer the questions. And that's how you get credit for attending. Whether you watch the live lecture or the recorded lecture, that's how you get credit, all right? Okay, so let me go back to the whiteboard. Okay, so today we are talking about summarizing and graphing data. This is the part of descriptive statistics that we talked about last time. And these are some important characteristics we see in our data. So we're looking at what's happening in the center. All right. We're also looking at the variation. And variation is the measure of the amount that the values vary among themselves. Then we're looking at the distribution of our data, whether it's bell-shaped, it's uniform, or skewed. Then we're also looking at outliers. Maybe there's some sample values that lie far away from the vast majority of other sample values. So these are characteristics that we will be looking at as we look at our data. When we graph our data, we're using histograms to graph. We're using histograms to look at what shape our data is taking, and these are the different characteristics that we're looking for. Okay, so histogram is one of the first graphs I'm going to show you. There's some others, but we're going to focus on a histogram first. Later on, we're going to look at box plots, and so there are many other graphs. Okay, but these are the characteristics that you are looking for. Okay. All right. So I asked you a question. I asked you a question on the survey that you completed. And one of the questions was, it says, estimate how many miles you travel to get to Grossmont College. And so that's the distance from your home to the college. Okay? Now, these are the answers that I got. And so right now, it's just a lot of numbers. And we call that raw data. Now, I had 4 students who did not answer. No answers for 4 students. So I had 95, but then 4 students didn't answer. There were 99 people who responded, but 4 students did not answer this question. So then my sample size then has to be just 95, the responses that I got. Okay, so that's our sample size, just 95. All right, so what we first have to do is we have to take this data and we have to organize it, right? We organize it using a table. And so this is the part where we're going to use descriptive statistics. We're not making any conclusions. We're just looking at our data and organizing it, summarizing, and just presenting what's happening using graphs and tables. I'm not making any conclusions, okay? I can't make a conclusion about our population of Grossmont students based on your responses. I'm not making any conclusions or any generalizations. So I'm not doing inferential statistics, I'm just doing descriptive statistics. Okay, so when we're organizing and summarizing data, when I'm organizing and summarizing data, we put that in a frequency table, or we call this frequency distribution. So when you have large data sets, it's very helpful to organize it. And we construct a table. It's known as a frequency distribution. Computers will do this for us. StatCrunch is the software we're going to be using to help us create a table, to help us create this frequency distribution table. Of course, calculators could generate these as well. I'm going to use StatCrunch to construct these frequency tables. Okay, so a frequency table lists classes or categories of values along with frequencies. The frequencies are your counts, and they're the counts of the number of values that fall into each class. So this is what happens. This is the raw data that I collected. Okay, there's the raw data. And of course, it's just a bunch of numbers. Right now, I don't know exactly what's going on until I organize it. So on StatCrunch, I created this frequency table, and look what it did. So it took my data and it broke it into various sections. We call those section classes. So that's what it says right here. So each section is known as a class. So here's class 1, here's class 2, class 3, class 4, class 5, and 6. Okay, the raw data here is put into where it belongs. So if you look at your raw data, the numbers between 0 and 4.99, there must have been 23 of them because our frequency is 23. And from 5 to 9.99, if you look at your raw data, there are 23 of numbers that fall between those two values given. So I left one blank, and I want you to look at the raw data and tell me how many values fall within 25 to 29.99. All right, so you guys see it? Okay, so about 4. All right, so I'm going to do the polling just because it's sometimes this one was a quick question, so this one didn't take too long. But yes, it would be 4. So you see how the raw data I had to make those bold. all the 25s, I went ahead and I bolded. I didn't find anything greater than 25. So then what we would do is you go to the raw data and we see that there's only 4 numbers that fall between the 25 and 29.99. So that's how you create it. Okay? All right, so there's another thing we see here. The frequency, if you add up your frequency, the symbol that we would use to add up is sigma. So the sum of the frequency is equal to, if you add up the frequency column, this is frequency, we end up with 95. Now it happens that 95 is also our sample size. So the sum of your frequency will always equal your sample size, which is n. In statistics, n represents the size of your sample. Lowercase n will represent the size of your sample. Okay, so we have our table, we have our frequency table. So the next thing we're going to go over is what do we call these values? Because right now I'm just saying, you know, that's the first class, that's the second class, the third, fourth, and so on. But there are we have a special word for all these numbers. And so we're just going to go over definitions right now, okay? All right, so this is what I've already said. I talked about the sum of your frequencies, how it's equal to your sample size, which happens to be 95. So we know there are 95 values. So I just finished talking about that. Okay, so here are the definitions. Or this is the terminology, and we're going to go ahead and match these up to the different numbers. Lower class limits, upper class limits, class midpoints, class boundaries, and class widths. So we have our frequency table. The first thing I have for you is the lower class limit. All right, so the lower class limit, let me see if I can use a highlighter here. The lower class limits are the smallest numbers, and I'm highlighting them. They are the smallest numbers that can actually belong to the different classes. So remember we talked about how a frequency table partitions your data. So we have the first class, the second, the third, the fourth, and so on. And so the lower class limits, those are the smaller values in your class. Okay, that's the smallest number that can actually belong to that class. So we call that the lower class limits. And then we have the upper class limits. Well, you can guess what the upper class limits are. I'm trying to get the highlighter back again. There we go. So the upper class limits are then these numbers. They're the largest numbers that can actually belong to the different classes. So the data value, the largest data value you can put in the first class is 4.99. That's the largest data value. The largest data value you can put in this class is 29.99. Okay, so those are the upper class limits. And then we have class boundaries. Okay, there are 2 ways of doing class boundaries. One method is easier than the other depending on the student. And so the class boundaries are important because when you get to your histogram, when you get to look at how your data is behaving, we need to label everything accordingly. All right, so the class boundaries are going to be those numbers that connect your classes together. So every class here is going to be represented by a bar on your histogram. So let me see if I can fast forward to that just so that you see what I'm talking about. So that's a histogram right here. That's the picture of your data. And so every class here is represented by one of these bars. So the first class is the first bar. The second class is the second bar, and so on. And notice the frequencies, they go up to that height. The vertical axis, that's your frequency, that's your count, and so the first bar will go up that high. All right, so the histogram is then a picture of what's happening in your data. Okay, so when the class boundaries, and I have to adjust this because StatCrunch doesn't give this to us. So I'm going to have to erase these numbers here, and I'm going to have to fill them up with the boundaries. So I'm going to redo this, and I'm going to give you the numbers that actually go here. Those would be the class boundaries. Okay, so I'm going to go back to where it says class boundaries. I think it was this one. Nope. There we go. All right, so here are the steps. You're going to find the gap between your classes. So where does this class end and where does this begin? So you see, that one ends and that begins. So that means we are looking for the difference between where that one ends and that begins. We call that the gap. So what does it seem that the gap is in here? So between 4.9 and 5. Between 4.9 and 5. All right, so the popular answer is 0.01. Good. 0.01. Okay, so the gap here is 0.01. Now it has to be the same. It has to be the same for all of these. So I'm done with the first one. So let's look again at the next one. All right, so the gap between 4.9 and 5 is 0.01. Now, is that the same from 9.99 to 10? From 14.99 to 15? So you need to make sure that it's the same. And so we agree that it is. Okay, so 24.99 and 25, the gap is 0.01. So the gap is the distance from where one class ends and the other begins. Okay. Once you have determined the gap, you're going to divide it by 2. Okay, so if I divide that by 2, we have our gap, which is different depending on your data. In this case, it's 0.01, but if we had another frequency table, it would have been something different, right? So you divide it by 2, and I see you guys saying that you're getting a 0.005. Good. All right. So that 0.005 for this particular frequency table is going to be added to the upper class limits. So you're going to add it to these numbers right here. So you're going to add 0.005, and I'm going to list them down here. So 4.99 plus 0.005. Okay, so that's 4.995. So I'm just adding them to my upper class limits, okay? All right, so what I've just finished doing is I just added that 0.005 to my upper class limits. That's what this part says. Okay, now it also says that you're going to subtract from the lower class limits. Now these are the lower class limits. So we're going to subtract. So I'm going to put minus 0.005. We're going to have some overlap, but that's okay because then it just verifies what we already have. So you're going to subtract 0.005 from 0. So that's going to be negative 0.005. Okay, now what happens when I take 5 and I subtract 0.005? So now I'm over here. So 5 minus 0.005. Okay, that's interesting. We get what we already have here, right? That's where the overlap begins, yes. Okay, now the same thing here. Then what you see is when you move it down and you take 10 minus 0.005, then you get the next class boundary that we've already written here. So we get this 9.995. So 10 minus 0.005 gives you the next class boundary, and so on. Okay? So when you add to the upper class limit, that starts giving you your class boundaries. When you subtract, that gives you the extra class boundary that the first one didn't give you. So that's why you need to make sure you add to the upper class limits and then subtract to the lower class limits so that you get them all. There's a lot of overlap, and that's okay. You don't have to write them down twice. But you just need to make sure that you have all of them. So you need to make sure that you have the ends. By doing both of those, you have the ends, the first and the last class boundaries. All right, so that's one way of finding class boundaries, and this is important because when you get to your histogram, which is right here, that's how you're going to label the horizontal axis. Now, these numbers are not here. I am erasing them. That's not supposed to be there. We're going to replace this by our class boundaries. So the numbers that we just found, they're going to go here. All right, they are going to go here on the horizontal axis. So when you get to looking at the picture of your data, that's where we're going. All right. So what was the first one? I remember it was negative, right? So negative, oops, that was way too much ink. Virtual ink there. Okay. So it was negative 0.005. Yeah, that's where we started. Okay. So negative 0.005. That was the first class boundary. Right, so that's right at the corner, and then the next one is at that corner, the next one at the corner, and so on. So that's where your class boundaries are going to go. All right, so be prepared to put your class boundaries there. Now, in an effort not to go back and forth on the screen, I'm just going to go ahead and write these in here. Negative 0.005 is where we start, and then we have 4.995. I think that was another one. You see how I'm writing them as a diagonal? And that's because I can't fit them in if I write them horizontally. So 9.995. So I'm just copying the class boundaries that we've already found. Okay, now the word miles is in my way, so I'm going to erase that. And anyway, I'm just continuing, and I'm labeling this. All right, so in algebra, you were always told that if you're starting at the origin, you start at 0, right? And that's not what we're doing here, is it? Okay, so here we're not starting on 0 on the horizontal scale. And we're not going to the left of 0, even though we have a negative number. But that's okay when you're constructing histograms. The important thing to keep in mind is that the width of the bar has to be the same. So the width of every bar has to be the same. So when you look at this, what would you think the width is? All right, so you all think 5? Okay. So yeah, so it looks like the width is 5. So, and that's why we have to start this at negative 0.005, because that's what's going to give me a width of 5. If I start at 0, that's just 4.995, and I need a width of 5. That's called a class width. Okay, so your class width here is 5. That's how wide each of the bars is going to be. Now, notice that in a histogram, there are no spaces between the bars. If you had spaces between bars, then you would have a bar plot, not a histogram. And I will show you bar plots later. Okay, so I'm going to move back up to my class boundaries. There we are. All right, so those are the numbers that I just copied onto the histogram. The class boundaries allow us to mark the horizontal axis in our histogram. All right, and then I have another way of doing this. If you thought the other one was a little confusing, another way you can think about this is that the class boundaries, they connect your classes together, right? They connect your histograms together. So you could find where these two, what the in-between distance is. So another way to do it is if you look at 4.99 and 5, you can look at what the in-between distance is. So you take where one class ends and where another one begins, and find out what the middle distance is. So again, in a different color, you take where one class ends and where another one begins, the next one, where the next one begins, and you divide by 2. And then what you start seeing is you start seeing a pattern. Okay, so for the first one, we have 4.99 plus 5, well, that gives us 9.99. And if you divide it by 2, well, that's a 4.995. You got that? Okay. And then the next one would give you 9.995, okay, 9.995. Okay, now let's go back and see if these are numbers we ended up already getting. Okay, there it is, see? So we have 4.995 and 9.995. So you see how you start getting the boundaries if you do it this other way? So the method I showed you first, this is the method that the book uses. But if you think about the class boundaries being the number that connects the bars from your histogram, then you're pretty much looking at the midpoint, like what's between that upper class limit of one class and the lower class limit of another. So you're just finding the midpoint between those. Okay, so that's just another way of looking at it. What you start noticing, you don't get all of them this method, but what you start noticing is that they're going to be 5 apart, and that's our class width. And the same thing here. If you look at this, you see that they're all a difference of 5. So if you go from here to here, from here to here, at some point you see a pattern, and so if you just want to follow that pattern, then you can just keep writing down all your boundaries. So they all are separated by 5. So they're all a difference of 5. So then you need to make sure that when you go to your histogram, they're all going to be 5. The width of every bar is going to be 5. Okay, so now we're looking at the class midpoints. Now, the class midpoints is another way that you can label your histogram on the horizontal axis. And we'll go ahead and show that to you as well. So the class midpoint is just another way that you can label your histogram on the horizontal axis. The class midpoint is just the middle of your class. So you're looking at the lower and the upper class limit. So that's just the middle of your class. All right, so there was a question, and the question says, how do you find the negative 0.005 using the second method? That's the thing with the second method, you do not need that. So for this second method, you do not need to worry about the gap. You do not need to worry about dividing the gap by 2 because that's where that number came from. That negative 0.005, where was that? Oh, it was a negative actually, it was just positive. That 0.005 came from taking the gap between your classes and dividing by 2. And that's when we added it to the upper class limit and subtracted it from the lower class limit. However, if you're using the second method, then you don't have to worry about the gap or dividing it by 2. You can just take where the one class ends and the other begins. And when you do that, what you're doing, you're adding them together, dividing by 2, you're finding where the middle of that is. And so that's the class boundary as well. So in the second method, you don't have to worry about 0.005. So what you want to do is you want to decide which method is easier for you and stick with one of the methods. If you use the second method, you don't get all of the class boundaries, so you'll have to see what the pattern is. And when you see the pattern, you see that, oh, I have to add 5 every time on this one. And so then that you just have to make an adjustment when you get to your histogram. You have to make sure that you've labeled all of the corners. So when I did that here, so you need to make sure that all of these are labeled. And if you don't have enough, but you see the pattern, then you just keep adding 5. Now you know it's not always 5, right? It's just for this particular frequency table, the class width just happened to be 5. Okay. All right, so I may have answered that, or someone may have done a better job at answering that question, but it looks like you understand. Okay. All right. So the class midpoints, you're looking at the middle of the class, so that's 0 plus 4.99. If you're looking at the middle of the class, you're going to add them and divide by 2. That gives you the middle. That gives you the midpoint. So to get the midpoint, you're just looking at the middle of the class. So 5 plus 9.99, and then dividing it by 2. Okay, you're going to continue doing this. Here's another one. I'll do one more. And I'm on the third class. So again, to find the class midpoint, you take the lower class and the upper class, divide by 2. Okay, so this is what I have for the class midpoints. For this first one, I was changing colors and then that's taking too long. So for the first one, when you add the lower and the upper class limit, divide by 2, you get 2.495. So that means 2.495, that's the midpoint for the first one. That's right in between the 2 class limits. And again, you find the next one. And the next one. Now, maybe you see a pattern here. So I can probably stop. So does anybody see a pattern? All right, so I'm going to list my class midpoints. And if you notice what the difference is here, again, you add 5, then you just continue with that pattern. All right, so I have 6 classes, so I need 6 class midpoints, so I can stop. Now, the class midpoints, that's another way of labeling your horizontal axis on a histogram. You have the option of using your class midpoints instead. But if it's the class midpoints, then the marking that you make on a histogram, shouldn't be in the corners. But if it's the class midpoint, it should be in the middle. So your class midpoints are going to be the middle of your bar, not the edges, not the corners like we did the other histogram. So the class boundaries go on the corners, but the class midpoints go in the middle of your bar. All right, so again, a difference of 5. We call that difference the class width. So when you see class width, now we know what the answer is. And there's a question about how I made the histograms. I did use StatCrunch for that. And for your first project, you are going to make histograms as well on StatCrunch. So I will give you instructions for how you would do that on StatCrunch. You will be able to take this data, create the frequency tables that I'm showing you, and create histograms as well. So that's the class width. Now you know it's the width of your histogram. And there are many ways you can get the class width. All right, so there's some guidelines for frequency tables, and this just gives you some guidelines. Now, nowadays with technology, and you have StatCrunch, you're going to be using StatCrunch, is you're going to create the frequency tables using software. You're not going to do these by hand. But there are some guidelines in the textbook. If you go to the ebook, you'll see that they do have instructions for how to do it by hand. But you know, we're going to use technology for that. Okay, but there are the guidelines, and this is what we try to stick with. All right, so I've already showed you the graph of the data. So this is just your definitions, but just so that you have it here. But we want to, once we organize our data, we want to be able to look at how it's behaving. And a graph does exactly that. It shows us the distribution of our data. And so later, we're going to be, the shape of our data is going to be really important in the few chapters coming up. And we're going to often refer to a distribution as it having a normal distribution. And so if your data has a normal distribution, that means it's bell-shaped. And I'm going to draw a bell-shaped distribution just so that you know what it's talking about. So that looks like that would be a bell-shaped distribution. So that means that your histograms, the bars in your histograms, they start low, and then they start getting, the frequencies start low, and then they go up high to a maximum height. And then what happens is that they come back down. So the frequencies start low, then they go up to a maximum height, and then they start coming down low again. So if that's what the histogram is doing, then you have a normal distribution. But if the histogram is not doing that, if the bars in your histogram don't start low, reach a maximum, and then come back down again, then you have some other type of distribution. Okay, so this is coming up later. We start talking about it, chapter 6 actually. It's a little bit in chapter 3, but that's coming up. Okay, so here is just a definition for a histogram. You already know it's a bar graph, but there are no gaps in between. It's a bar graph, but there are no gaps in between. And so on the horizontal scale, we're going to use class boundaries. I already showed you that. You also have the option of using your class midpoints. Now the vertical axis, that's your class frequency. That's the frequency. Okay, but I've already showed you all that. And we've already seen this before. All right, so that's how the frequency table that came from the raw data, that's how it matches up to the histogram. Now, is this distribution normally distributed? So in order for it to be normally distributed, we would have to start, the bars would have to start low, go to a maximum, and then go low again. All right, so there's a question. Emily, did you mean to ask a question? You can just type it in the chat area. All right, so yeah, if you have a question, you want to make sure you type it out. I don't see it typed out. Okay. All right, so I'm going to go ahead and see what other ways there are of organizing our data. So what do you guys think? Is this a normal distribution? Is our data normally distributed? It's not bell-shaped, right? Yeah, it doesn't look bell-shaped. So what I want to do is I want to take a look at your data from the survey. Just from the class survey, I want to look more at the data that we had. This one, again, we were talking about how far you live from campus. Okay, so we have more tables. And this one is called a relative frequency table. Now, relative frequency, it gives you the information in percentages. We can turn these into percentages. It's just a different way of displaying what's happening in our raw data. So over here, we had the regular frequency table with the counts, right? We have our frequency, which gives us the counts. Over here, we have a relative frequency. So now information is given to us a percentage. Now we turn all these decimals into percentages, right? This is a formula. That's how we find a relative frequency. So what we're going to do is we're going to take the class frequency and divide it by the sum of all frequencies. All right, so the class frequency for the first class is 23. So we're going to say 23, and then the sum of the frequencies, well, that's what we said in the previous slide. That was our sample size, right? 95? Okay. All right, so you're going to take 23, which is the current frequency, and divide it by 95. That's going to give you a decimal, which you can turn into a percentage. All right, so there probably should be another column on here so that you can go ahead and write down what the percentages are. All right, so for this one, if you take 23 divided by 95, you get about 0.24. I'm not going to put as many places after the decimal. StatCrunch gives you all these values after the decimal. And yeah, they're pretty close, aren't they? It is the same because they're both the same frequency, right? Yeah, you're right. So they're both the same frequency, so it'd be the same thing. All right, so we're going to write this as percentages. And so when you write it as a percentage, this could be written as 24.2%. Just keep it about one more place after the decimal. So again, 24.2%. And then this one would be 25.3%. Now we have another one to fill in here. That is, that class had a frequency of 17. So according to the formula, I have to take the class frequency divided by the sum of all frequencies. So what did you get, Allie? You got 0.1789 something. Okay, and if we turn it into a percentage, okay, now let's round this accordingly. So 17 the 9 makes the 8 a 9, right? So 17.9%. Good. So don't forget about your rounding rules. All right, and so this one would be 4.2%. So remember, you're turning all these into percentages. All right, so that's just another way of presenting your data. And so you have it as a percentage, so you know, okay, students, let's see, what percentage of students live less than 10 miles away from campus. So less than 10 miles away from campus. So you're looking at these two groups, right? So less than 10 miles away from campus. So we're about 24.2 for both of them, right? Yeah, it's about 48.4%. So it's pretty close to half of you. So half of the students are local, right? You're between those two. Okay. So about half of the class lives less than 10 miles away from campus. Okay. So just another way of presenting the data. All right, so I just remembered something that I should disclose to you. So this data came from a class survey. And I just realized, just looking at this, it was not specifically for the online class. So this was my face-to-face. There is a question on today's lecture, lecture 2 assignment that you're going to access. One of the questions I asked you was, where did I get this data? So this data came from a class survey. That's what you're going to say, that it came from a class survey. The options I give you was class survey, the textbook, public sources, but this data came from the class survey. So if I collected a survey from you, I'm going to use that one to show you StatCrunch so you can see the results, and then I also use that for exam questions. So I need data for exams. I need to construct histograms, and I need to construct tables. And so what I do is I take whatever survey I've given your class and I make questions from that. Okay? So I just realized, I was like, no, I know we have some students that are even outside the country. I'm sorry, not outside the country, outside the state. So they're out of state. So that obviously doesn't come to play here. So this comes from a class survey, not necessarily your class survey. Okay, so look what happened here. So this is the same table. I've already filled it out here. But when I copied it, obviously the blanks are still there, but we've already taken care of the blanks because we just did that in the previous slide. From a relative frequency histogram, you can construct, from a relative frequency table, you can construct a relative frequency histogram. So from this table, you can construct a relative frequency histogram. Look at the shape. I'm going to remind you what the other histogram looked like. And I'm going to put them side by side. Yeah, so I try to resize them so that they should be the same because they're supposed to be the same height. But the distribution, yeah, the distribution is the same. You do not get a different distribution. So a histogram obtained from a frequency table is going to have the same shape as a relative frequency histogram, which was obtained from a relative frequency table. So the distribution is the same. So it doesn't matter which table you use. When you construct a histogram, it's going to have the same shape. Now look at the vertical axis. They're not counts. No longer are they counts, but now they refer to the percentage, right? There's nothing above 25%. Well, this one's 25.3%. That's why this goes all the way up to about 25%. Okay, so 25.3%, that's this one right here. All right, so the program rounded it to 2 places. Okay, so the shape is the same. Now I'm going to give you an option for the horizontal axis. Remember, we talked about the class midpoints. If you chose to use the class midpoints for a horizontal axis, then this is what it would look like. So let me erase what's already there because that's not supposed to be there. Okay, so the horizontal axis represents the miles, how far away you live from campus. All right, so I'm going to put in the class midpoints as a horizontal. So on the horizontal axis, we're going to fill in class midpoints. All right, so as I'm getting ready to do that, let me answer that question that was just posted. And the question is the shape, if the shape is the same, is the only difference of a regular histogram and a relative frequency histogram the percentage? Yes, that would be your only difference. It's what the vertical axis is. So the vertical axis is your difference. That is a percentage instead of a frequency count. All right, so let me go ahead and give me some time to show you where those class midpoints would be. Remember that it's a class midpoint, so it's the middle of the class. So we have already wrote these down somewhere. And I'm going to have to do something here to make all my numbers fit. I believe the first class midpoint was 2.495. And then I'm just going to do this to make them all fit. So this was 7.495. All right, I'm having some issues here with the pen. So 7.495, and then this is 12.495, 17.495. So you notice the difference. They're all a difference of 5. 22.495. And the last one is 27.495. So they're the same class midpoints from the other slide. So notice how when I put them on the histogram, they're the middle. It's the middle of the class. Okay, now StatCrunch doesn't do that, so I always have to edit things. So that's one of the things I don't like about StatCrunch is when it comes to labeling the horizontal axis, it doesn't use the labeling that the textbook talks about. Okay, so so that's why you see that I'm editing that. Okay, so that's the option on the horizontal axis for either a regular histogram or a relative frequency histogram. All right, so Allie, did you have a question? You can type it out. So if you type out your question in the chat area, I can see it. Okay, so then what I have here, we talked about this. Okay, so we have one more table to look at, and this is called a cumulative frequency. A cumulative frequency. So it's just, again, another way of presenting your data. So if the question was, how many students live less than 10 miles away from campus? Well, the table's already set up for that. It says it right there. Less than 10, okay, that's 46. So basically, the reader doesn't have to look at the table and then add the numbers. And so when you see it, it's in, it's not with the lower and the upper class limits. It doesn't have the lower and the upper class limits. It's probably a little bit more friendly to people who may not find the regular frequency table easy to read. So it's supposed to make it easier to get information. All right, so then how do we find out how many students live less than 15 miles away from campus? How many do you think from our table here would live less than 15 miles away from campus? All right, so most of you say 70. Some I see said 60, so let's find out why there'd be a difference there. Okay, so less than 15. Well, less than 15 would include the third class and everything that comes above it, right? So you have to make sure that you add all of these, right? So you see how that ends up being 70. All right, so what you do is you look at the current class and then just add everything that comes above it. So the current one is 24, and then just add everything that comes above it. So that's how we get a 70. So it's just another way of presenting your information, your data, describing what's happening in your raw data. But it's always more helpful to look at all these tables than it is to look at the raw data. It's very painful to just look at the raw data. That's what we started with, or it's just a bunch of numbers. But if you take the time to put them in tables, either a frequency table or a relative frequency table or a cumulative frequency table, any one of those tables gives you more information than the raw data. Just down here it says an ogive is a graph, and it matches up to the cumulative frequency. You don't have to worry about an ogive. I'm not going to have you draw or construct any ogives, but it's just there for information. Another important graph that we have is a dot plot. And it's just an easy graph. I mean, it's all you do is it's sort of like a number line, right, where you just take your data values and then you just tell me how many 5s you have and just put dots on top of the numbers that you see. All right, and so that's what we see here. It's just a low-tech way of looking at the distribution of your data. All right, so I just saw a question that was posed, and Margaret did a great job of answering that. Thank you. All right, so in this case, we see that we do not have a normal distribution. And here you can tell that there are 4 data values that were 25. That's why there are 4 dots on top of the 25. Okay. So let's go. When you see me silent, that's because I'm reading the chat just to make sure everything's good. So thank you for answering the questions. That's great. Okay. And then we have the scatter plots. Okay, another question that was asked on the survey was to tell me the height. Well, I asked you like a few questions. One was tell me what your shoe size is and your height in inches. Shoe size and your height in inches. And then the other one was to tell me what your mother's height was, or what your mother's height is, and what your father's height is. Okay, so the first question I have for you is, and you know what, I said I was going to use the poll and then I didn't. I think it's because I have to type it out. So I think next time I'm going to make it part of my PowerPoint. So let me see. I think that probably would work better. In the past, I've never had this many people. We have the class was a little structured, a little different, so there was no need to do the polls. Okay, so oh, my text is a different. Okay, so let me just change the color. I was writing with white type. Okay. All right, so is there a difference between these two graphs? I just want to see what you guys think. Don't type it out. I'm going to use the poll. Is there a difference between the two graphs? All right, so I'm going to move it here. And don't say anything yet. I'm just going to, so you can vote. Let me just clear the previous vote. And A is for yes and B is for no. So if there's a difference, say yes for A and B is no. All right, so let me type that as A means yes and B means no. What do you think? You can vote. Remember how I showed you at the beginning how to vote? All right, so using right by where you raise your hand, that last button, you can vote on what you think about these two. So I'll give you a minute to look at it and vote. This also gives me an idea of how many of you are in attendance, because when you're voting, I see how many of you have voted for A and how many for B and so on. So Jesse, did you have a question? Or you could type it out on the bottom. Okay, yeah, that hand is right next to the other button, so maybe by accident it was pressed. All right, so what you're doing is not typing it, but you're voting at the top, right? Okay, so let me go ahead and publish. And next time I'm just going to make this part of the PowerPoint, because then I don't have to spend time. All right, so this is what we have. Okay, so most of you think, yes, that there is a difference. All right, so here's the poll. Okay, so is there a difference between the two graphs? So the answer to that is yes, there is a difference. So, okay, you missed how to vote. Okay, yeah, that's fine. I mean, I was just trying it out. I think what will happen next time is when I do the PowerPoint, I'll make the questions part of the slide, so that way I don't have to spend time typing it out, because I noticed that that's not very, it's not a very efficient way to use my time. But I just wanted to try this out, make sure it's all working. So this is where everybody's at. Okay, so you see how this graph, how as you go from left to right, it looks like they're increasing. But this one, it just looks like a blob of points there, right? It doesn't seem, nothing interesting seems to be happening there. All right, so the question about your shoe size and your height, that's the first graph. So you see that someone who has a size 12, who wears a size 12 shoe, they're pretty tall. Okay, so the smaller size, they're usually shorter. All right, so what this seems to say is that the larger the shoe size, the taller the person. Okay, all right, so this has a linear pattern to it. It has a linear pattern. Now that's not the case for everyone, right? Here's someone with a size 12 shoe. However, look, they're not that tall. Okay, they're not that tall. All right. All right, so someone is trying to vote, but you're pressing the hand. So it's the next button, not the one with the hand, but the one right next to it. There you go. All right, so then, yeah, I mean, it's not the same for everyone, but that's the general trend. That's the general trend. And there are exceptions, like here's one size 12 shoe, but they're not the tallest in the group. And so you can see that that's outside. And so the good question would be, is it an outlier? And in chapter 3 is where we kind of talk about what data values qualify as an outlier. So this would seem like maybe something that may qualify. So yes, we're going to be talking about outliers. But that is the trend here. It seems like the larger the shoe size, the taller the person. So if someone's investigating a crime, right? If a police officer is investigating a crime and they see a footprint on the on the dirt, and they see footprints, if it's a size 12 or a size 14 shoe, what conclusion can they make about the individual they're looking for? So that's what's more likely to, right? They're looking for a tall person. Now, of course, that person might be the outlier, right? Or someone who's doesn't actually fit the trend of the data, but that's probably who they're going to be looking for. If it's a size, the shoe size is large size, the person's probably going to be tall. It's probably a tall person. All right, so we're going to talk more about this in Chapter 10. Linear regression is a topic that we are going to find later. We do look at the behavior of our data, and here we are looking at two variables, and we're trying to see if the two variables are related in some way. That's what a scatter plot allows us to see, if the two variables we're looking at are related to each other in any way. And here we see a linear relationship. Later we're going to get into more of the vocabulary that we use with scatter plots. Over here, there's no linear relationship. The question here was estimate your mother's height, your father's height. So for this one, the question I would have here is, do tall men marry tall women, or do tall women tend to marry tall men? So just from looking at this, let's see. Do tall men tend to marry tall women? So I have a few no's. Okay, so slowly the no's are winning. Okay, yeah, so it's not really. If tall men tend to marry tall women, then our graph would look more like the graph on the left, because then the taller, yeah, it would be more of a linear relationship, right? So tall women would marry tall men. So this one who's 70 inches would marry someone who's 70 inches. Or someone who's 55 inches marries someone who's 55 inches. So it would be more of a linear relationship, okay? So there doesn't seem to be a relationship. Now there is a question that says, I think height distribution in gender is different, and you're right, it is different in gender. But still, what you would see more of a linear relationship. So even though women's height is different than men's height, when you compare it on a scatter plot, if there is a relationship, even though the units are, the two groups are different, we still would see a relationship. We still would see something linear. But yes, that's a very valid comment to make, that there is a difference between the two groups. Okay, so you've seen a lot of tables and you've seen a lot of graphs. And so I did all this using StatCrunch. Okay, so what I'm going to do right now is I'm going to take about a 5-minute break. I'm going to give you a 5-minute break, and I'm going to pull up my StatCrunch data, and I am just going to go ahead and create these tables and graphs so that you can see how I'm doing that. You will get a StatCrunch assignment. I haven't released it yet, it's too early in the semester, but you will get a project, and I will give you instructions. But I just want you to get familiar with how StatCrunch works. Okay, so I'm going to do a 5-minute break as I get set up here. So it's about 1:45, so about 2 o'clock I'm going to come back, okay? All right, so I'll silence this. Those of you who are watching the recording, it doesn't matter because you are just seeing the whole recording, so there's no pause on your end. Okay, so we are back. And so I am going to share my desktop with you. So what you should see right now is my data. Okay, so if you have data, and this is again from a survey, from a class survey, and this happens to be spring 2015. When you are on My Stat Lab. When you're on My Stat Lab, there is a button for StatCrunch down here. Okay, so on the navigation area, you have a StatCrunch button. So you can get to StatCrunch right from within My Stat Lab. It has a link right there. It has a link. If you click it, it'll open up, right? And that's what it would look like. And so that's where I'm navigating from. So if you just want to open StatCrunch, you just open it, and if you happen to have data in there, you'd go to Data. Okay, so I'm going to just make sure that I am sharing what I want to share with you, and not something else I shouldn't be, because I have the actual survey that has the names on it, and I don't want to show you that. I want to show you the anonymous data. Okay, here it is. When I opened it, it took me to somewhere else. Okay, so here's our data. It's anonymous, right? There are no names attached to this. Okay, so it's pretty intuitive, this StatCrunch. If you want to create a graph, you're going to go to where it says Graph. And that's how you'd create graphs. We have histograms, we have scatter plots. There are many options. But we started off today's lecture talking about tables, right? So to get to tables, I had this on the whiteboard as well. You're going to go to Stat, and this is exactly what I had on the whiteboard, and then you're going to select Tables. We want frequency tables. So you go ahead and select that. And then these are the variables. I've been looking at miles because that represented how many miles you are away from campus. Now you could ask just for a frequency. If you want a relative frequency and a cumulative frequency, you can do all that together. I'm just going to stick with frequency for right now. If you wanted all three, you can press the Shift key and then select the rest. So the Shift key and then select. But I'm okay, just frequency is fine. The defaults, all the defaults could stay. So go ahead and click on Compute, and it says, wow, there are a lot of unique numerical values for miles. So do you want to turn on binning for this procedure? Yes. So look at the frequency table. All right, so this frequency table doesn't give me a lot of information, right? It's like, okay, so 66 of you are within 100 miles of the campus. Well, I kind of want to know more about those 66 of you. So this frequency table, I'm going to have to kind of work with my data. I'm going to have to play with that data. And there is one person who has, it says 454. So that's the first one I saw. So what I'm going to do just for this exercise, I wrote it down, so I'm going to enter it back later. I'm just going to leave that blank just for the purpose of adding a frequency table that's a little bit something we can understand. That number will be very important for other things, so I want to put it back in there. All right, so I'm going to go to Stat, Tables, Frequency, and then I'm going to choose miles. Okay, and then we're good. All right, so now we have a table. It looks different, right? Just remember that we do have, and this is something that you can edit, we do have one person who's 454 miles away. So you have to make a place for them on this frequency table, but StatCrunch doesn't do a very good job of that. All right, so my options here, I want to copy this, and I'm going to just open a Word document. When you try to do that, it gives you instructions on how to copy. That's what this is, okay? So Control A and Control C. So I say Control, I click on the table and do Control A, and then I do Control C to copy it. You can just open any Word document. All right, so just confirm that you can see the Word document that just popped up. Someone, yes, okay. So you go to your Word document and then just paste it, do Control V, and there's your table. Okay, now here we have the option of editing it. All right, so one thing that StatCrunch does, if you notice the upper class limit and the lower class limit, they're the same, aren't they? Okay, but what did we say in lecture? That we didn't see that they were the same. So that's the problem. If you had someone who lives 20 miles away from campus, where would they go? Would they go in the first class or would they go in the second class? It's hard to know, right? Because 20 is included in the first class and it's included in the second class. So I actually went through the raw data, and this is the way StatCrunch is doing it. So this 20 that's here, that's actually 19.9999. I just put 2 nines in there. That 40 is actually 39.99. 39, not 29. 39.99. Okay? So you have the power to edit that. Once it's on a Word document, you can edit it. And then that 80 is 79.99, and so on. 139.99. And that one's 159.99. Now I do have to make space for that the individual who lives, and I could just say, well, I have to figure out how to put that in there, but we do have one person who is 454 miles away, so we'll put that person there. Okay, so there are some things that you may notice on this. So we did say that StatCrunch gave us something that didn't have gaps. All right, and that's one thing that I don't like about this, because there are no gaps. So the number 20, if you find that someone lives exactly 20 miles away from campus, where would they go? Are they in the first or are they in the second class? So that's why what I'm doing when I went to my Word document is I'm editing that. I'm editing all that. Okay, so now we do have gaps. 19.99 to 20, we have gaps. From 39.99 to 60, we have gaps. Okay, so that's actually, when you go through the data, that's what actually StatCrunch is doing. When it says 0 to 20 on the first class, it's actually just going to like 19.999, and that's what it's doing. So editing this is just, it's just what it's doing. Okay. All right. So the other thing I want to see is I want to see if all my class widths are the same. So the first one goes from 0 to 19.99. Right? So look at the difference between your lower class limits. You go from 0 to 20, and then from 20 to 60, and then from 60 to 120. So are our class widths the same in this example? They're not, really. They're not. Okay. So there's a question, and let's see, I lost the question. So yeah, so for the first class, it goes from 0 to 20, but we put 19.99 so that we don't put 20 in 2 places. That was the whole problem, is that if you had a data value that's 20, then you have where do you put it? So that's why I edited these. Okay, but even by doing that, what we notice here is the class widths are not the same. And in real life, that's what happens. That is what happens. So you have to make the adjustment. So what I showed you in the lecture, that's like a textbook. I mean, I went through the definitions and I went through textbook examples. But if you go to the real world, this is what you're going to end up seeing. So there might be a way of redoing this frequency table. Look, there's 59 who live between less than 20 miles away from campus. I probably would want to look further into this group right here. That's 59 is a lot. So I probably want to look more into that group. So I would probably put anyone who lives from anywhere above 60 miles away from campus, they would just get their own class because there's not that many of them. So above 60 miles away, there's 4. So they would just get their own group, okay? And so I would probably, I would have to look at these 2. So for something like this, where it doesn't exactly follow what the definitions that I gave you, you kind of have to, it takes more thought about how we're going to arrange this. Okay, so this is something I'm going to be working on and giving you all the different possibilities on this. Okay, all right, so that's how you create a frequency table. All right, so now I'm going to go ahead and look at graphs. So for graphs, any graph, we have bar plots, which is kind of like a histogram, but it has gaps. So it's a graph with bars, but it has gaps in between. We have a pie chart. We have a histogram, which is what I showed you. So let's go to histogram. So it'll be interesting to see that histogram. That so we know we have 4 individuals who live far away. So how does that change things? All right, so I'm going to do compute. And so there we are. So the problem with this is I need to figure out how to create my graph. Oops. So you see what happens when you click on your graph. It tells you where those data values are. I just don't like the pink, but it tells you where the data values are. So I'm just going to clear that because the pink is not very pleasing to my eyes. So I'm just going to get rid of it. But what I'd like to do is I'd like to find out what's happening in this group from 0 to 25. Okay, so I have to redo this, have to work with my data to make that, so that gives me more information. Okay. All right, so let's try. So we didn't get anything pretty from this data. So we have to, I'll have to look at that and give you some options during the next lecture. Okay, so let's try the scatter plot. So there's the dot plot. Here's the scatter plot. Okay, so I'm taking your shoe size and your height. So shoe size and height, shoe height. All right, then we're going to hit compute. So this is a scatter plot. The x-axis is your shoe size, and the y-axis is your height. Now, what I showed you on the notes looked really similar to this. So there's a relationship between shoe size and height. Of course, there are exceptions. So here's someone with a size 8 shoe, but they are 52 inches. All right, so there are exceptions. But still, the trend is linear. And so there's a question. Is StatCrunch like SPSS, which is another statistical software? And I think that's used more in social sciences. I think StatCrunch is a little easier to use. SPSS, I used it maybe 20 years ago, and I remember writing, it was not very user-friendly. There's still a lot of code. So StatCrunch is supposed to be much easier to use. But yes, it is a statistical software. We have something else. There's something called S+, which I believe now is R. So there are other softwares. And this one, I mean, it's free with my StatLab, which you already have. If you wanted to have StatCrunch after the class, I believe it's about $13 every 6 months. So it's much affordable than some of the other statistical softwares out there. Okay, so let me go ahead and change this to, instead of looking at the shoe and the height, let's look at your mom's height versus your dad's height. Now, with the other data I showed you, there is no relationship. And again, there's a blob here of points. So it doesn't look like there's a relationship between the two. So tall men do not tend to marry tall women. Well, there's no relationship, I should say. There's just no relationship between mom's height and dad's height. Okay, so let's just look at some other options here. So we can do pie charts right there. The reason I'm showing this to you is because I know that there are a lot of you out there who may have a job where you have to deal with data. So this gives you software that you have available because of the class. So you can do all this on your own. You can just create all these graphs. So here's a pie chart, and I want to see what's going on with the university you're planning on transferring to. Okay, so right away we have more than 50% of you are planning on transferring to SDSU, and you have the other breakup there. So other, 31%. You know, if half of the pie chart is colored in, that's 50%. So you can kind of see that the red is a bit more than 50%. And so you have your percentages on the side. As far as I'm going to edit and I'm going to change what I'm using here. So instead of the university, I'm going to see what self-service you have. So who do you get self-service from? All right, so you can see that. Now, the university you're transferring to, that's nominal data, right? So notice that I'm using pie charts for nominal data. Self-service is nominal data. Okay, so let's see, most of you are, well, it's a tie between Verizon and AT&T. I think more of you, if you look at the numbers on the side, 28.36 are with AT&T. Okay, so again, it just gives me an idea of what's going on in my data. I don't know, what other nominal data did we have? So we have male, female, gender. Okay, so more women than men in the class, more females than males. Okay. If we see any more nominal data, we can do a pie chart for that. I think that was it. Whether or not you have a smartphone. All right. So 68% of you have an iPhone. And 23% of you have an Android. All right, so again, it tells you quickly what's going on with your data. All right, so that's some of our nominal data. And there are other things. So maybe we can try history. Oh, how about a bar? Yeah, let's do bar plots. So bar plots look sort of like histograms, but they don't have any gaps in between. Okay, so let's look at this. Let's see. How about the month you were born? Okay, so month is what kind of data? How do you have January, February, March? So what kind of data would you call that? So we have nominal, ordinal, ratio, and interval. There's an order to it, right? January, February, right, so ordinal. So we would say it's ordinal, just the way I'm looking at it anyway. So it's either January, February, March, April. Those are the answers you gave me. So it identifies what month you were born, but it also has an order to it when you look at it. So I'm going to do a bar graph for that one. All right, so notice that I'm not changing any of the defaults. You could change the color scheme. You can make it a different color. You can label the X and the Y axis. You have a lot of options. All right, so that's a look at when most of the birthdays are. So it looks like March has 9 of you have a birthday in March. Okay, so notice that your bar plot has gaps. So if you give me a bar graph with gaps, if you're giving me a bar graph and it has gaps, that's a bar plot, not a histogram. A bar a graph that has bars in it and no spaces, that's a histogram. So you see there's a difference between a histogram and a bar plot. And I keep saying that because on the test, I get a lot of people doing bar plots when I'm asking for histograms. So there is a difference. All right, let me do another one. This one's just for fun because I want to give you some time to go through that assignment so I know that you watched the lecture. I'm going to do another bar plot, but I'm going to do it for the number, the random number. I asked you to think about a random number. And let's see what most of you picked. Okay, I typed something. There we go. Random number. So, okay, most of you picked number 7. All right, let's do this again. I asked you to select another random variable, right? Or another random number from 0 to 10. So that was when I asked you to pick another random number, and I labeled it random number 2. So I'm curious to see what was the most popular number. So this is the second time I asked you to select a random number. So again, most of you selected 7. That's kind of interesting how that happens, right? So, and you know, when we talk about during the class, we're going to talk about probability, but this kind of gives you an idea as to these are things that happen, you know, here with humans, where if you ask more than 30 individuals to pick a number from 0 to 10, the majority of them will pick 7. That always happens. So if you're asking, you know, more than 30 people to pick a random number, the majority of them are going to pick 7. That always happens. So that was just interesting just to see that. But now that you know that, next time you're asked to pick a random number, maybe you won't pick 7. So that might change the distribution for that survey. Okay, but I just thought that was interesting to see. All right, it's going to be it's always 7. 7's the majority. Okay, so that's all for StatCrunch that I'm going to show you right now. What I want you to do next is I am going to just go back to my stat lab, and under homework, there is lecture number 2. That's how you get credit for watching this lecture. All right, so when you click on it, there's 3 questions. All right, so you're going to go ahead and open up your My Stat Lab, go under homework, and look for that assignment. So I am going to stay logged on. You go ahead and finish that. If there's something I did not talk about, let me know. But I believe I talked about everything that's on here. Okay. Yeah, and there's a question about, is it always going to be 7? And yes, it's always 7. I do this every semester. I send out a survey, and you know, one of the questions is pick a random number from 0 to 10, and then I ask them again to do it. And yeah, it's always, the majority is 7. So that's always interesting to see, and you know, just behavior, human behavior. And there was a study, I guess, about when you go to the public restrooms. When you go to public restrooms, like there's certain stalls that are used more than others. So it's like if you collect data on it, you see that the very first one next to the door is hardly chosen because human behavior, we think that most people choose that one, and we're all thinking, okay, that's the most used stall, and so then we go to the next one. And so so it's interesting how, you know, it kind of talks about, you know, looks up human behavior. But okay, a couple of questions. All right, so I will answer that in just a minute about if you missed a lecture. So remember that if you're not here for the live lecture, you can always watch the recorded lecture. Okay? So if you hang on, I'll show you where to get that. Okay, so let me just go through the questions, make sure I answered all of them. So during lecture, which data did I use for the presentation? We talked about that. Data in a frequency table. Okay, I didn't say this one. So data in a frequency table is also referred to as grouped data. So when you have data in a frequency table, it's grouped. It's known as group data. We have raw data and we have group data. And group data is what we call once it's on a frequency table. All right. So I'm just going to click on number 2. Okay, so it says during lecture, which data did I use for the presentation? And I answered that question, right? All right, so go ahead and go through that. I'm going to stop the recording because, of course, I don't want them to just fast forward to the end. Okay, so I'm stopping the recording. All right, so there was a good question that was asked. So let me take you back to, I just don't want there to be any confusion. I did not mean to confuse on this one. But during lecture, which data did I use for the presentation? So for the presentation with the lecture notes, I used data from last semester, just to go over the definitions and all that. But when I opened up StatCrunch, I used data from this semester, what I collected this semester. All right? So hopefully no confusion there now. All right, and then the rest, a histogram and a relative frequency histogram obtained from the same raw data I have. Okay, we did talk about that. A dot plot helps us see how our data is distributed. We talked about that too. A scatter plot helps us to see the relationships between two variables. During lecture, we looked at the scatter plot of your father's height and your mother's height. According to the scatter plot, tall men tend to marry tall women. So we answered that question. Which data did I use with StatCrunch today? So today I used data from the class survey. Okay.